So structure questions from topic 8, which is periodic table. You can use my chat or screen annotation to answer these questions. Some group 7 elements react with aqueous solutions containing halide ions. When aqueous chlorine, means the chlorine dissolved in water, is added to a potassium bromide, the reaction happens. Ionic equations for the reactions are shown. Describe the color change. So what actually happened? We have potassium bromide KBr and we add chlorine. As a result, it will produce potassium chloride plus bromine. So what is the color? The solution, this is colorless, does not have any color. This will also be colorless. But what about the final mixture? Even this is colorless, potassium chloride, but bromine is colored. Bromine, bromine, when it is pure bromine, it is red brown. That is right. But because it is an aqueous bromine, it is dissolved in water, so aqueous bromine is orange in color. So you're not supposed to say red brown. Even brown is acceptable. I'm not saying it's wrong, but in the actual color, it should be orange because when bromine dissolve, this brown is acceptable. But the correct color should be orange as aqueous bromine is orange in color. The next is identify the species that is oxidized. Oxidized means oxidation, which is a loss of electron or the one which has an increase in oxidation number. So when we check for chlorine, the oxidation number of a chlorine is 0 here. And the oxidation number of a chlorine is -1. So 0 turn into -1. So this change is a reduction. For bromine, this is -1 and 0, -1 and 0. It has increased in oxidation number. So this change is oxidation. So species which is oxidized, that is bromide ion. You're supposed to write, if it is a bromine molecule, we'll write Br2, but if it is a bromide ion, we write Br with a charge -1. An explanation, what is the explanation for oxidation? Because it lost electron or it loses electron or its oxidation number increase. But in exam, whenever you're writing the oxidation or reduction, try to write in terms of electrons. Don't write in terms of oxygen or oxidation number. Whenever there's a definition of oxidation, the best answer it should be in terms of electrons. Oxidation is a loss of electron and reduction is a gain of electron. Is it clear this one? The next one is you have to calculate the overall energy change using a bond energies. So energy change, whenever we want to calculate the energy change, it is bond breaking minus bond forming. So bond breaking minus bond forming is equals to enthalpy change or energy change. Bond breaking, bromine, bromine, it is 190. Chlorine, chlorine, this is a bond breaking side, 242. That's the bond breaking energy minus the bond forming energy, BRCL. For each bond, it is 218, but there are two bonds, so it should be multiplied by 2. So this will be 432 minus 416. So we'll get the enthalpy change for this reaction. 432 minus 416. So we'll get 16. So sorry, this is 436. By mistake, I wrote 416. 436 here. So when you subtract, you will get a -4. If you are getting a negative answer, it means this reaction is exothermic. So in energy profile diagram, the reactants will have high energy and the product will have low energy. This will be enthalpy change and this will be the activation energy. This is what we already did, like we solved. This was about the Page 5 about periodic table: aluminium, carbon, iron, hydrogen, oxygen, silicon, sodium, and sulfur. These are the elements. Answer the following question using these elements. You can use them once, more than once, or not at all. Element that can be used as a fuel. So what we can use as a fuel? The element which we can use, that's good, hydrogen. Name the element that form oxide which is similar to that of diamond. So that is a silicon 4 oxide. Name the element that form amphoteric oxide, means which can react with both acid and alkali. Remember the amphoteric oxides of zinc, aluminium, and lead. These are amphoteric oxides. Name the element that has oxidation number +2 and +3, means the transition element. We have iron here. Name the element extracted from bauxite. Now, which element we don't extract carbon from bauxite, we extract aluminium, because the ore of aluminium is bauxite. Name the element that has atom with the electronic configuration of 2,6. So group 6 element we need. So group 6 element is oxygen. Iron rust when it is in contact with oxygen and water. How sacrificial protection prevent rusting? Sacrificial protection means we don't completely cover the iron. We just place a more reactive metal. So iron is connected with a more reactive metal. Either they can be overlapping on each other, or they can be connected by a chain. So when a piece of iron is connected with any more reactive metal like magnesium, so as a result, what will happen? Oxygen, more reactive metal, loses electron first or oxidize. And as a result, this more reactive metal oxidize, which prevent the iron from rusting. So 2 marks are there. You're not supposed to write the detail. Sacrificial, the more reactive metal protect the iron, and you have to mention in terms of electron as well. Like more reactive metal loses electron first or oxidize, electron transfer from magnesium or more reactive metal to iron. So it is preventing iron from oxidation. State one other method. What we can use galvanizing, or we can also use a paint. The marking scheme answer for the part B. Yeah, galvanizing is correct. If you see the marking scheme answer for, so a higher metal reactive or more reactive metal, any metal you can name, and it oxidize or react and it prevent. It's a 2 mark question. The same question they can ask 4 mark. So in that one, you have to write the detail in terms of movement or transfer of electrons as well.